1/5 x. Isn't that what's left? Yeah. So I don't know exactly, I mean, I don't, without dividing, I don't know what the y-intercept is going to be for that equation, but I know that the slope of it is going to be 1/5 x. Now, in a minute, we're going to talk about the end behavior of that thing. So let's talk about that real quick, because I think some of you have a little fog in your brain here. We need to get the fog out. I don't even need the rest of it. Don't care about any of that stuff. This is all I care about right here. Because when I talk end behavior, I look at the biggest power. That's what I look at. So when I start messing with that, doesn't that come down to 1/5 x? Now there's more, but I asked you for the slope of the asymptote. It's 1/5. Now what does y equals 1/5 x look like in terms of a shape? It's a line. And does the line go up or does the line go down? Up. So I don't know exactly what that asymptote is, but I know that it has this slope, which means that to the right, this isn't part of this particular problem, but it's a part of a problem coming up. To the right, what is happening to my curve, whatever it looks like? Remember, it's going to be approaching that asymptote, right? That's what an asymptote is. We approach it. So as this thing heads to the right, to positive infinity, what is its behavior? It is getting increasingly large. It's getting closer to the asymptote, but what are the y values doing? They're heading to infinity. And what about on the other end? Because that is the asymptote, what do I know is happening on this end? The y's are going down. So you can tell the end behavior of your picture without sketching it. You can tell the end behavior. I don't know the exact shape. You're right, I don't. But I know the end behavior by simply looking at my slant asymptote. If the slant asymptote were negative 1/5, then wouldn't the picture be going like this? So on this side, I'd be positive infinity, and on this side, I'd be negative. All that can be told just from considering the asymptote. Now, even further than that, what if this had been x to the 4th? Then I wouldn't have a slant asymptote, exactly. But I would have an asymptote. What would it be? It would be an x squared. So whatever funkiness would happen in that problem, what would be the end behavior? The same as the asymptote. So in this case, since that's positive, it would be up, up. Would you agree with that? Which, we're not going to use that vocabulary on the test. We will say positive infinity on the test, but that's the behavior of it. Okay, guys?
So do we only write the limit notation like with the asymptote for horizontal asymptotes? Like, or we say if it's coming from like down or up?
I'm not sure what your question is. You're going to use limit notation whenever it says describe the end behavior.
Okay.
Anytime it says describe the end behavior. That is not what's happening on this worksheet right here. It's saying write the equation of the asymptote. I ask you to give me the slope because I want you to make sure you understand that you can tell the end behavior of anything by examining the limit. Okay, how about H? What's going on in H? Does H have or H, number 3, 3 is H. Does 3 have a horizontal asymptote? Yep, and it's y equals 0. Perfect. Does K have a horizontal asymptote? No. It has a slant asymptote though, right?
Yes.
And what would be the slope of that asymptote? Positive 3. Positive 3, right? So the equation would be, if you did the division, it would be y equals 3x plus or minus some number, right? But for end behavior, all I care to know is that the slope is 3. Because that means on the left I'm going down and on the right I'm going up. The curve, the end behavior of the curve is going to be the same as the end behavior of its asymptote. okay? Okay. All right, how about 5? What's happening there?
Yes.
Yes, there is a horizontal asymptote, and it would be y equals 10. How about Q?
No.
No. It does have a slant asymptote though, and its slope would be 1/3. 7,
Yes.
yes, and its equation would be y equals 9/2. How about 8?
Yes.
Yes, and its equation would be y equals
-1.
-1. Very good. Did everybody catch the negative there? -1. And what about 9?
No.
Not horizontal and actually not slant either, right? So we've talked about these non-slant asymptotes. This course does not go into that. That's just extra information for you guys because you're brilliant. Okay, number 10, write limit statements for the end behavior. Now I want you to look at problem 10. Does it have a horizontal asymptote? So the limit on both sides is going to be whatever the asymptote is, which is 1/3.
Yes.
Because, again, think about it, as we go off the page, if our asymptote is horizontal, won't we be approaching that? Either from the top or the bottom, I don't know, but I'm going to be approaching that line as I go off the page. The horizontal asymptote is the end behavior of the picture. The slant asymptote is the end behavior of the picture. All right, what about 11?
8/3. Horizontal.
It has a horizontal and it's 16/6, which is 8/3.
Yes.
So your end behavior, I'm gonna cheat here, it looks just like that. If it's a horizontal asymptote, the end behavior is gonna be the same on each side, because you got one asymptote that's going straight across. And what about number 12?
Slant
Gonna have a horizontal and it's gonna be y equals 0. So your end behavior with limit notation is simply going to be 0. Yep.
We're not gonna have like the plus and minus because we are not graphing.
We are when we do a picture.
Okay.
Yeah, we have a picture, yeah. Rena? Yeah, we'll use it from our picture. So we're gonna do it right now because now we've got actual pictures. Okay, so we can be real specific with the picture. Now, some of us get so like, we overthink things. I want you to look at this problem, number 13, and I want you to read it and notice that it says, the input values are decreasing without bound. So if the input values are decreasing without bound, where am I looking in my picture? On the left side. So it asked me to write one limit statement, and it's going to negative infinity, because it tells me in the problem the inputs are decreasing without bound. So this is what's happening to the inputs. So I want to know, okay, what's happening to the outputs? Well, look at your picture. As you go left in number 13, what's happening? We're getting closer and closer to -1. And since we have a picture, we can even specify that we're getting closer to -1 from the top. That's it. We're done, because it said we're decreasing without bound. Okay, now look at number 14. Now we are increasing without bound, which means we are looking for this limit, right?
Right side.
I guess it's G. okay? So what's happening on the right with that guy?
One.
Getting closer to 1, also from the top? Okay, now, 15 has a slant asymptote. We are increasing, our x's are increasing without bound. So take a look at that slant asymptote. Where is it heading on the right side of the picture? Up, forever. So what's the curve doing on the right side of the picture? Up. Yep. And finally, the last one on this page, we are heading toward decreasing, so negative infinity. So we're going left. Where's my curve going? Up. So that's another positive infinity, because the curve's going up. Josie?
So when there's a slant asymptote, we use like the infinity and negative infinity, and when there's a horizontal, we use that horizontal asymptote
Now, wait.
in the limit
I want
statement.
you, stop, Josie, stop. This isn't something we're memorizing, okay? And you can if you want, but you need to think about this. What are we talking about here? When we say we're finding a limit as x approaches infinity, what are we talking about? End behavior, that's right. And if the end behavior of the picture is shooting up into space, if the picture is shooting up into space, what's its end behavior? Yeah, there's no number. It goes on forever without end. But when you look at one that has a horizontal asymptote, what's that curve doing? I get that it's, let's say, getting smaller and smaller and smaller, but it's not getting smaller and smaller and smaller, like down to negative infinity. It's got a floor, right? That's its end behavior. Yep. Okay, next page. Find the zeros. I can't remember if, I can't remember if we even talked about this. We talked about solving inequalities. So this is real easy. Remember when we looked at this equation, something like this? And we said, let's say this was an inequality and we were gonna put dots on the number line. Where would the dots go on the number line? Negative 3, 2, negative 5, and positive 1, right? All those are important points. They are different in terms of the inequality. So if this was like this, which is the one we looked at the other day, then we start testing numbers and checking and all that. But if we are graphing this, which is eventually where we're headed, then all of these are very important points, but they're different points. The numerator gives us the zeros of the rational function. So the numbers that come out of the numerator, which would be negative 3 and 2, are the zeros. What do we mean by zeros? The x-intercepts. The x-intercepts. So, again, we're not graphing this today, but if we were, we would start by plotting a 0 at negative 3 and a 0 at 2. Okay? Now, the dots that come out of the denominator are the cannot be's. Remember, we said no matter what, that's going to be an open dot and that's going to be an open dot because you cannot be those two values. Cannot be's are vertical asymptotes. So if I were sketching this, I would have a vertical asymptote at x equals negative 5 and a vertical asymptote at 1, if I were actually going to sketch this whole picture. So when you look at a rational function, all the numbers are important. Every factor is important, but the top ones give you your x-intercepts and the bottom ones give you your vertical asymptotes. Okay? So let's look at the next problem. In number 2, it only asks me for the zeros, but let's go ahead and add the asymptotes in there. The zeros are where for number 2?
0, negative 2, and 1.
The only 0 I have is 0. Because where do zeros come from? They come from the top. Now again, if this were an inequality, I would draw a number line and I would have dots at every single one of them. But in terms of the vocabulary of the problem, the numerator is gonna give me the zeros, so the only zero I have is 0, right? And then my vertical asymptotes are gonna be x equals 1 and x equals -2. Would you agree? Okay. How about, oh wait, number 3. Tell me what's a little bit strange about number 3.
You got 2, x minus 6, and one's in the numerator, one's in the denominator.
Okay. And what do we do, Xander, when we have a situation like
Oh, we
that?
can just take those out. I
We
believe.
just take those out. They are actually called removable discontinuities. When you can remove them from the problem. Now, that adds an extra piece to the problem. You guys talked about this last year. I know you did. Maybe you forgot. But let's back up. Look right here. Where's my only 0? My only 0 is 3. Where's my only vertical asymptote? 2. Now, when this happens, when you have a factor that you can remove, technically called a removable discontinuity, otherwise known as a hole in the picture. Remember talking about holes last year? Holes in your picture come from anything you can cancel out. So, if this would have stayed in the problem, you would have had an asymptote at 6. Well, instead, you're now gonna have a hole at 6. Wherever the asymptote would have been, that's the x coordinate of your hole. Now, I need a y coordinate. Holes are like points. How do you suppose I'm gonna get the y coordinate? Plug in 6. Now, don't try to plug it in the original, because it won't work. You gotta plug it in here. So if I plug in 6, it looks like I get 3/4. So again, we're not sketching, but if we were, we have an x-intercept at 3. We have a vertical asymptote at x equals 2. And now I know I have a hole or an open dot in my picture at 6, 3/4. And by the way, you already know the horizontal asymptote is at y equals 1. See how close we're getting to being able to actually draw these things. We're putting all the pieces together. Why did problem number 1 not have a hole? Nothing canceled out. Nothing canceled out. Okay. Let's look at number 4. What do you think we're going to do with number 4?
Factor it out.
We're gonna factor it. Always factor, gang. Always factor. Sometimes it will help, sometimes it won't, but you've got to factor to get all the facts of the problem. Okay, assuming that I factored correctly, am I gonna have any holes in this problem?
No.
Nope. Am I gonna have any zeros? Yep. My zeros, my x-intercepts are gonna be at 5 and -4. My vertical asymptotes, I know it didn't ask for it, but just make a little note. Your vertical asymptotes are going to be x equals -5 and x equals 4, right? No holes. Our horizontal asymptote is where y equals x squared over x squared, y equals 1, right? All right, for number 5. Let's factor it. What do we got? X plus 3 minus 3. And x minus 5 plus 3. Make sure I did that right. Uh-oh, see why we factor? What happens? We're gonna have a hole in our picture. Now, the zeros and the asymptotes are going to come from your reduced problem. There is one zero, and it is where x equals 3. There is one vertical asymptote, and it's where x equals 5. But because of the cancellation, this one is also going to have a hole, a removable discontinuity, something we can remove from the problem. Where is that going to be? Well, look at what you canceled. That's gonna be where x is -3. Look at your original problem. Wherever you were gonna put an asymptote, that's where you're gonna put your hole. Alright, plugging in -3 is gonna give me what? 3/4? Did I do that right? Alright, let's take a look at number 6. Do the same thing. So we're gonna have to factor first. Stop here and make sure I factored correctly. Anybody get that? Where are my zeros?
0, 8.
0 and 8. Where's my vertical asymptote? X equals 1/2. How about a horizontal asymptote? Don't have one, right? But we do have a slant, and its slope would be 1/2. All right, we also have a hole. Where's that hole going to be?
-4, and
-4 something. So let's put that in here. So -4, -12. Did you get 48/9 or 16/3? It's not okay? All right, we're only gonna do one of these in 7, 8, and 9, so which one do you wanna do?
I would do
9?
Yeah, what's the
All right, let's do 9. Okay, so use the graphs to solve the inequalities. All right, so here we go. Notice that it's greater than or equal to 0. So I will be looking at only the part of the graph from here up. Would you agree with that? Okay. So what part of the graph is from there up? Remember, it's x intervals, so here we go. Negative infinity to, remember, we gotta be positive. So won't it be negative infinity to -2? And should I include my -2?
Yeah.
Remember, you gotta be up here, so we got this little thing up here, that's what we're looking at. Now, aren't we also looking at this piece?
Yeah.
So what's that?
Parentheses, -1, and then 0 with the bracket.
What do you think, is Xander on target there? Remember, asymptotes are cannot be's, so they're not included. Vertical asymptotes are never gonna be included. All right, and then, oh gosh, isn't that whole thing positive over there?
Yeah.
So that will be what?
1 in parentheses, 2 infinity.
1, 2 infinity like that, would you agree? So you are looking, when you have the graph, you are looking for greater than 0 is above the x-axis, less than 0 is below the x-axis. Okay, we did a lot of these the other day, but just for fun, you and your partner do number 10. And remember that we're showing, let's pretend this is a test and we're showing our work. Okay, so make sure that you got your number line. And then you're doing your sign thing, S-I-G-N thing. Make sure that work is being shown somehow. I just got the little section in between. Did I do that right? I made a mistake to start with. Is that okay now? -2, 1, okay? All right, let's try a couple of these on the back. Again, we're not gonna do them all, but let's try 12, 13, and 15. So 12, 13, and 15. And then let's throw in 18 too. So while you're at it, 12, 13, 15, and 18. Twelve, 13, 15, and 18. Just trying to pick random interesting problems. When you've got one you're happy with, go ahead and put your answer on the board. You don't have to put all your work up. We'll do the work if somebody's got a question. But we'll just look at your answer. What'd you guys get for number 12? I'm just gonna start putting the answers up here, we can talk about it in a minute. What'd you get here? Negative infinity, open or closed? Closed. So let's talk about that. Let me see if that's what I got. Bryce is saying, Bryce wants to argue about this problem. And I think I'm in Bryce's camp. Should that be a closed one there? No, because even though the symbol in the problem is or equal to, remember that the denominator cannot be 0, ever. So I think we're all good as long as we make that a parenthesis. Is there anybody that's got a question about that?
Just these ones that are nominated,
Just the denominator dots, as if the symbol is or equal to. If it's not or equal to, then none of them are gonna be set. All right, what about 13? What did you get for that one?
Negative infinity to 0.
Open or closed on the 0?
Open.
Open. Everybody okay with that one?
I see that one.
You got a dot at 0 and a dot at 4. They're both open because of the symbol in the problem. If you put in a negative number, any negative number, the top is gonna be negative, but the bottom is gonna be positive because you're squaring it. That works, okay, that's what I want, negative. If I put in 2, the top is positive and the bottom is positive, that does not give me what I want. If I put in 5, the top is positive and the bottom is positive, that doesn't give me what I want.
I did that first.
Okay, what about 15? You put an answer to 15.
Yeah.
What?
Negative infinity to negative 4.
To negative 4.
Closed.
Closed, okay.
Unified with closed 3 halves to positive infinity.
That's what I got. So on that one, I hope when you drew your number line, that you actually had 3 numbers marked on your number line. 0 from the bottom, right? And then 3 halves, oops, 3 halves and negative 4. Remember, every 0 of the top and the bottom, every key number from the top and the bottom has to show up on your number line. Okay, what in the world happened with 18? Everything was colored? Kids? There are no zeros for the denominator, so no dots are coming out of the denominator. Is there a dot coming out of the numerator?
Yeah.
Where is it? 3? Is that dot open or closed? Open. So when you checked your regions, you're looking for things that are positive, and you probably got positive over positive and positive over positive.
Yeah.
So you colored all this in and you colored all that in. Is that everything? Except for 3. So negative infinity to 3 or 3 to infinity. If the problem had been an or equal to problem, then that would have been a colored in dot, and then your answer would have been negative infinity to infinity. Makes sense to everybody? Okay. All right, now I'd like you to look at that next sheet that says recap. Let's look at the recap sheet. So while you were doing something, I handed out some other papers. One of them is called recap. All the stuff that we just got done talking about. So find the ending in your asymptote. What do we got in A? Y equals 4/3. Horizontal, right? What do we have in B? Y equals 0. What do we have in C?
There is no way.
There's no horizontal asymptote, but there is a slant asymptote, right? And without having the whole problem, there's no way I can figure out exactly what it is, but what can I figure out? The slope is -3/4. So it's a slant asymptote with a slope of -3/4. How about D? Be careful, is that a slant asymptote? No, that's gonna be some huge 5th degree weird shape thing. So, I don't know how we're gonna say that. No horizontal or slant asymptote. No horizontal or slant asymptote. That's all our course cares about, so that's what we're gonna write. Julia?
For C, do you want us to write like slight aspect with slope of -3?
Because our course covers slant asymptotes. Okay, and then what about E? Yep, y equals -1/8. Aren't you gonna have an x squared on top and an x squared on the bottom? And the ratio will be -1/8. Good. Find the zeros, vertical and horizontal asymptotes, holes, and y-intercept. Oh, wow. Wow, wow, wow. All right, here we go. What are we gonna do first?
Factor.
So x minus 5 plus 1. And let's see, that's gonna be 2x squared plus 3x plus 2. So that's gonna be x plus 2 plus 1. Is that okay with everybody? Did I do okay? I don't wanna mess that up. Okay, so now I need my zeros. We're not asked to graph this, so, I mean, clearly we can make a list. I'm gonna just go ahead and put it in a picture. You can do that if you want, or you can just list it over to the side. What are my zeros? Oh, wait a minute.
We can cross off the
We
one.
can cross those out. So we've got x minus 5 over 2x plus 2. Now, where are my zeros? 5. One of them. Right here at 5. That's the only one I've got. How about vertical asymptotes? -2. Remember, whether you're drawing it or just listing it, and you're allowed to just list it over to the side, it's an equation. It's a line. So its equation is x equals -2. Don't just put -2. It's x equals -2. How about a horizontal asymptote? Does this thing, which is the original problem, does it have a horizontal asymptote? Where is it? Y equals 1/2? Again, I am drawing it in the picture. You can just make a list of it and say, okay, the horizontal asymptote is y equals 1/2. Don't ever put 1/2. It's y equals 1/2. A holes, do I have one? Yes, and where would it be? Where x is -1. Then I'm gonna plug it in and I will get -3. So -1, -3, I have a hole. And how about a y-intercept? How do I find, look at this problem right here. How do I find a y-intercept? I let x be 0, I plug in 0. So that's gonna give me -5 over 2 times 2, -5/4. graph this picture. You've got everything you need. Does it make sense to you that it's gonna look like that? Think about it for a second. Remember, these are all points on the graph, so when I connect them, does that shape make sense to you? And then what about the other half of the picture? The asymptote, cut your paper in half. You've got the right side sketched. What about the left side? Where do you think it is?
Over the origin?
It's right here. Now, can somebody tell me, why did I draw it there and not over here?
It's gotta be the sense.
First of all, this thing's a function, and would that be a function? No. You're gonna have a section of your graph on each side of your vertical asymptote. How did I know it was up there and not down here like this? Because I have shapes that look like that. How did I know that wasn't right? Do I have a 0 over here? No. The beauty of knowing where your zeros and y-intercept are, that's the only places you can cross an axis. So the minute I put that 0 there, I knew I wasn't gonna have any over here, and my picture was gonna have to look like that. Mrs. Ford, how do you know it doesn't just do something like this? Because as it goes off the page, it has to approach its asymptotes. So it has to get closer to 1/2, and it has to get closer to -2. See how easy that is? All right, let's try B. We can factor, but it isn't gonna, we're not gonna have a whole. Would everybody agree with that? What are we going to have though? Because of those factors, we are going to have two vertical asymptotes. So we're gonna have one at x equals -2 and one at x equals 2. Do we have a horizontal asymptote? We do. What is it? 0. So y equals 0. Oh, this is gonna blow your mind. Do we have a 0?
Yes.
Where is it?
7/2.
7/2. Now, who right now is starting to twitch? Because we just put a point on an asymptote, right? And I agree with you that, 40 years ago, I would be twitching, or 50. I'd be twitching, okay? But I don't anymore because I truly understand what a horizontal asymptote is. A horizontal asymptote is an end behavior asymptote. That means that at the ends of the picture, the curve approaches that number. This is not considered the end of the picture. Anything can happen in the middle. Technically, we never draw it this way, but technically, that asymptote doesn't go all the way across the page. That asymptote's out here, and it's out here, because that's the end behavior. We can cross horizontal asymptotes. You will never touch a vertical asymptote, because vertical asymptotes cannot be. You cannot be 2, you cannot be -2. But horizontal asymptotes are only asymptotic out here at the end. The curve can do whatever it wants in the middle, but out here, one way or the other, we're gonna cross it. Okay? I know hold, a y-intercept. What's my y-intercept? 7/4. Let's just talk about, because eventually, I mean, it's a couple days tomorrow, next week, we're gonna be wrapping these things, we might as well jump in. Can anybody figure out what in the heck this thing looks like? It has 3 pieces, okay? It's got a left, a right, and a middle. I think I know what's happening in the middle. Do you know what's happening in the middle? I think it's some kind of parabola shape. Now, I'm gonna go ahead and sketch it that way, but it may or may not be a perfect parabola. But it has to go up and up here, because if it came down, wouldn't there have to be a 0 in here? And there isn't. So the minute I put that y-intercept up there, I'm thinking up and up. Now, over here, the curve is either gonna look like this or like this. Would you agree with that much? I have no idea. So I am gonna try one number over here, that's -2. I'm gonna put -3 in here. -3 would make the top negative and make both of these also negative. So if I put -3 in, I don't know what I get, but it's a negative number, which means, isn't it being graphed down here? Remember, it's all up here or it's all down here, because there's no zeros in there. So it's all up or all down. One number will tell me, am I up or am I down? Here, the same thing is happening. Am I coming up from the bottom or am I coming down from the top? What could I do? Plug in 3? And is it positive or negative? Well, 3 would be negative on the top and positive on the bottom. Guess what? That's negative. There it is. Wait. What do you think it does here? Probably keeps on going, but at some point, what is it going to have to do? Come down, because that's its asymptote, right? All right, guys, see ya. Have a good day. We'll continue this conversation tomorrow and move on. Although we kind of already moved on.